Section 3.7, chain rule. This section, we will find the derivative of the composite function given that y equals f of gx is differentiable. Step 1. Identify the outer function f and the inner function g. Let u be gx. Replace gx by u. Express y in terms of the u as y equals the function f of u. Step 3. Calculate the product dy by du and the du by dx. Step 4. Replace u by gx in dy by du to obtain dy by dx, which is the last step. The chain rule has two different versions, depends on which one is appropriate for the certain problem. The version 1, dy by dx is the product of dy by du and du by dx, or we treat it as y as a function of the u. U is the inner function. Version 2, the derivative of the composite function f of gx. F is the outer function, g is the inner function, is the product of the outer function and the inner function, where the first part, which is the derivative of the outer function, has the input as the original dx or the original input function. Examples. Number 1, suppose h is the composite function of the f and g. Find h prime at 1. If f prime at 2 equals 6, f prime at 1 equals 4, g at 1 equals 2, and g prime at 1 equals negative 2, we rewrite h as the f of the g of x. So we're going to use the version 2 to find the h prime, as h equals the f of the gx. So the h prime equals the f prime, which is the outer function with the input as the inner function g, multiplied by the g prime of x, which is the derivative of the inner function. And we are going to evaluate at x equals 1. So the s prime at 1 equals the f prime at g at 1, multiplied by g prime at 1. The g at 1 is 2 as provided in the problem, and g prime at 1 is negative 2. So the next step, we have f prime as the input 2 multiplied by the value of the g prime at 1, which is negative 2. F prime at 2 is given by the value 6. Therefore, the h prime at 1 is 6 multiplied by negative 2, or negative 12. Example 2. Let h of x is f composed with the g, and the px is g composed with the f. Use the given table to compute the following derivatives. The h prime at 4, which is the f prime of the gx multiplied by g prime of the x, where x equals 4. Replace the value x with the 4. So f prime at g at 4 multiplied by g prime at 4. From the table, the g at 4 is the value 3, and the g prime at 4 is 1 over 11. So the problem can be replaced with the value the f prime at the input 3 multiplied by the g prime 4 value, which is 1 over 11. And next, find the function f prime at 3 from the table. So f prime at 3 is negative 4. Therefore, the h prime at 4 is negative 4 multiplied by 1 over 11, or negative 4 over 11. Part B, p prime at 1. Function p is the function g composed with the function f. So the derivative of the p is the derivative of the g as an outer function multiplied by as an outer function g prime as the input f multiplied by the derivative of the input or the inner function. Evaluate at x equals 1. Replace x with the 1. So g prime for f at 1 multiplied by f prime at 1. From the table, f prime at 1 is negative 6. F at 1 is the value 3. Rewrite the right-hand side expression to be g prime at the input 3 multiplied by the value negative 6. Another value from the table for the g prime at 3, which is 4 over 11. Now we have the quantity 4 over 11 multiplied by negative 6 or negative 24 divided by 11.